So welcome to this special session on equipment for fortification, session 8, which is a very, very important session. From the agenda, we were supposed to also have equipment manufacturers join us, but you would all agree that when it comes to equipment, you need several accessories, and different companies produce different accessories. So whether it's a pump or agitator or mixer or tank, or even the pipes that are connecting different systems, we would need to have several equipment manufacturers to bring all the pieces together. So what we have tried to do is to, in the context of food fortification, is really to showcase how equipment for various food fortification systems are composed and, brought together and fabricated before we actually go into the actual deployment at the industry level, to have a floor plan and install the equipment and make sure they're functioning, and then ensure that the fortification unit within that complex system is set up in such a way that before the product goes into packaging, we can fortify, whether it's vegetable oil or wheat flour or fortified rice. It's fortified in such a way that it is homogeneously mixed before it goes into packaging. So this afternoon or evening or late evening or morning, depending on which part of the world you are joining this session, we are very privileged to have Dr. Danie Shajie, who works with PATH, to take us through this session on equipment for food fortification. And I just would like to maybe take a few minutes to also ensure that Dr. Danie Shajie is properly introduced. Let me just allow Dr. Danie. Danie, please, do you mind taking yourself off mute and introducing yourself fully? And then we can go into your presentation.
Sure. Thanks, Mawuli, and it's an absolute pleasure and delight to be part of this virtual fair. And I would like to take this opportunity to thank you and
Danie, what happened? I don't know if you're on mute.
You're not able to hear me?
We are not able to hear you.
Right. Yes, I can hear you. We can hear you. We can hear you. Yes. Let's go.
All right. Perfect. Thanks. Yeah. So thank you so much for this wonderful opportunity, Mawuli. And I would also like to take this opportunity to thank the Catholic Relief Services and all the partners who have done an incredible teamwork in getting this virtual fair on food fortification, which is kind of important aspect in terms of addressing the nutrition initiatives and particularly nutrition specific initiatives, whereby we provide with the targeted delivery of micronutrients. And just a brief introduction about myself. I am Danie. I am the technical lead for food fortification at PATH. Been with PATH for more than 4 years and majorly working on rice fortification. So I'm a food technologist by my study, and my major work has been in therapeutic food development and the equipments and machineries around it. been with Path and majorly worked on or working on rice fortification implementation in terms of setting up food fortification systems, putting up the blending units, the fortified rice kernel production systems, also majorly looking into how the quality assurance and the quality control components in terms of products as well as processes are put in place in production units, and also working in setting up along with my team on a digital QA/QC quality assurance and quality control platform where it offers a complete traceability. So majorly we are working in India and also in Sri Lanka, where we have set up a food fortification system and we have strengthened rice fortification initiatives. So I'm happy to be part of this discussion. I'll also be talking about some of the equipments that's been used majorly in rice fortification and flour fortification, and a little bit on oil fortification as well. So that's it about me, Mawuli. I'll start to present with the presentation.
Oh, Danie, please go ahead, and feel free to, if you need me to chime in anytime, I can also chime in, but please take the lead.
No problem.
And this is a plenary. This is a plenary session. So we are not going to break out into rooms. Danie and I will just be interchanging and providing any insights and taking questions and responding to any technical questions. And then we also have food industries on the line, and we'll be showing some of the systems and how it works at the industry level. So please, Danie, over to you. Just take the lead on this.
You're able to see the screen?
Yes, we are able to see your screen. You can put it into the
PowerPoint mode.
Yes, please. The presenter mode.
Yeah. All right. So very brief slides. I'll just quickly run through it. I'm not going to go deep into what kilowatt motor or what kind of a frequency or what kind of the most of those kind of integrities into it, but I'm just going to cover it on overall. But I'll be happy. My contact is here, and as a follow-up, if you wanted to connect with me, please do connect with me, and I'll be able to and happy to share the details in related to this equipment. Just a brief introduction about Path. We been working in rice fortification for a very long time, and we had been working in India intensively, also in other countries where we generated evidence, like in Cambodia, and in India we also started to put up the rice fortification evidences in supporting working along with other partners and putting up the policy, the operational guidelines, and also majorly worked with the private sector on setting up FRK production systems in the country, also putting up blending units, ensuring the uniformity in the blending, and we also worked in India. The operation is majorly government driven, and we have a large scale public distribution system where rice is one of the commodity that's been given for more than 700 million beneficiaries, and as of now all the beneficiaries in India are receiving fortified rice as a part of the public distribution system. But in Myanmar it's fairly different. It's private driven, and we worked in Myanmar, and we also worked in Myanmar in partnership with World Food Program. And recently we are working in Sri Lanka as well, where we set up the first FRK production system, and the country is taking the rice fortification to scale. So this is some of I'm just going.
Put it in the presentation mode. We can see your slide, but it's not in presentation mode, and then it has to. If you are moving the slide, then we can see it also move.
Is it not in the presentation mode?
No, not yet.
Okay.
Okay, now maybe coming up.
Just give me a minute. Yeah. Sorry for this technical glitch. Yeah.
Don't worry, Danie. Just take your time and bring it up. It will come up.
Yeah. Is it okay now?
Now Now we can see it. Now it's in presentation mode. So please go ahead.
Yeah. All right. So what path brings us? We are working in setting up. Mostly, we work with the private sector as well as with the governments. In terms of private sector, we work in setting up the systems, strengthening the systems in terms of FRK production, also regulating and mapping the supply chain, streamlining the supply chain. Our intensive work is on towards quality assurance and quality control and developing quality systems in terms of lab capacity building, not only in terms of lab capacity building, is not only in terms of setting up systems, but also making sure that right methodology and equipments are used for testing of micronutrients. We also have a full-fledged digital QA/QC system which has been rolled out in India, which is end-to-end traceability right from premix and till the distribution points. And the other, I'm just quickly running through this. The other points are, we also work in setting up center of excellences, because once we are phasing out of the project cycle, there will be sustainable mechanisms who can provide technical support to the governments, to the country, and there will be a kind of a sustainable mode of operations. Okay, coming to the process of rice fortification, probably you would have seen similar slides yesterday when one of my colleague took you on the fortified rice kernel production. For the process, it's a two-step process where initially we produce the fortified rice kernel from rice flour and vitamin mineral premix, and using an extruder. So I'm going to take you through the equipments that are needed for the fortified rice kernel manufacturing, and also I'll also be taking you through the blending units that will be needed to blend this fortified rice kernel with regular rice in a ratio of 1:100 or 1:99 on a weight basis. So the major equipments for setting up the fortified for the production of the fortified rice kernel is we need to start off with a pulverizer, which can grind the broken rice or any other rice, whichever variety that's been used in a particular region. So in certain cases where the idea of rice fortification came, like utilization of the brokens, which was once considered as a waste, but in certain places the broken rice is more expensive, and so in certain countries they directly use the rice flour into the as a raw material. So in that case, this might not be required. So we need to have a pulverizer, and then we have an initial preconditioner or a blender where we adjust the moisture content of the rice flour, probably to around 30-35%, along with RO water, and where the vitamin mineral premix is also added into it. Once this mixture has been made, and then it goes into the extruder. We use an extruder which is of a twin screw extruder, and it has different zones of heating, probably at least a minimum of 4 zones of heating to more than 8 zones of heating. The more the better. And it's a twin screw, and the temperature in the extruder, we don't go more than 70 to 75, and at the most it's 80. We have and we so we the one component with the extruder is that it is necessary to be present with the cooling jacket, so that you'll be able to maintain and stabilize the temperature. And there are huge operational steps that needs to be taken care of when you're running the extruder, in terms of you will be having an oil pump. We need to start off with the oil pump, and then there is a sequence of operations when you're starting or initiating off this extruder. And the extruder comes also with a cutter and a die cast, which makes it in the shape of the 45 rice canola, makes it in the shape of rice. So so the most important components might be the adjustment of the flow rate and the barrel screw speed, and the temperature zones, based on which the shape and size of the rice, as per the variety that you wanted to have, whether it's long grain or medium grain or short grain, can be modified. And that plays mostly with the operational parameters in the extruder. And once and also the other component in the extruder is the feeder flow rate. So the feeder flow rate also plays a major role at which rate it flows. All these rates, it changes with the equipment or the type of extruder that we are using, and also the temperature zones that we are keeping in. The more longer the barrel length, the better the product also. So once it comes out of the extruder, probably it will be around 20 to 25 percentage moisture. It goes into a dryer. So the critical compounds in the fortified rice kernel production is the extruder, and then this dryer. The dryer is a multi-layer dryer, and maintaining at 80 degrees or less than that temperature, where there are different types of dryers, electrically heated or air heated through air blowers. And the most important component is that it maintains efficient drying in terms of uniformity. And the other component is the how the dryer operates is it's a pulley driven dryer, and it falls from one layer to the other, and it operates. So the rate at which this belts moves are also plays a critical role, and the rate at which the air is also blown, it also plays a major role. If the belt is of a higher rate, then it won't be proper drying. If it is too low, then it's going to cause browning. And if it is too then sometimes it also leads to the cracks in the rice, and making the rice turn brittle. And once you just take it off and rub it in your hands, it sort of crushes. Or if you just put it into the water, it goes as a porridge or a mash. So drying plays a very critical role in the extruder operations. And once it's dried, it'll usually be dried to a moisture content of around 12 to 14%, and then it goes cooled and goes into packaging. So in between, there are several other equipment. So when you're once the important component is, if you have seen an FRK production unit, there will be conveying systems. So there will be air conveyors. There will be, so for from this blender to extruder, there will be screw conveyors through which the material is conveyed into the feeder hopper. And from the FRK, from the extruder, or once the FRK is being produced, it will be put into the vibratory chamber, and then then it is through air pumps, it moves to the dryer hopper, where it gets conveyed. And then once it comes out from the dryer hopper, it goes into a cooling tower. There will be a cooling tower where underneath it will be like a mesh like a system, and underneath that there will be several fans that will be put, which enables in cooling. And then again there will be a vibratory tower and a gyro swifter. The most important process is, sometimes during the extrusion operation, there are ways that the rice gets stuck to each other, and even in drying operations it doesn't separate. So the gyro sifter will help you to grade the rice as per the required size and shape that is needed. Yeah. And once it's once it comes out of the drying system, then it goes into the blending unit. I'll talk more about the blending unit in some time, where the systems where it is being blended in the ratio of 1:99 on a weight basis, and then goes into a packaging unit. The critical components when we are considering the fortified rice kernel production unit is also the humidity of the processing room that we are working in. It should be ambient conditions, and the humidity, which also can causes change in the drying operations. And the most important component is that all these equipments should be of food grade. And we should make a note that if you're following as per the ISO norms, all these should be food grade, and it should be SS304, stainless steel 304, which is of a food grade material, and it are not mild steel, where we have seen certain people using mild steel as well, but it should not be mild steel. And in terms of, yeah,
No, go
am
ahead.
I going too fast? Should I slow down?
No, it's good.
Pardon me?
That it's okay. There was
Okay.
a issue with the slide earlier on, but now it's clear.
All right. Okay. Coming to the blending operations, there could be batch blending system, where in batch blending you have or two different hoppers for FRK as well as normal rice, and then there are conveying mechanisms where sometimes people use vibratory feeder, and sometimes they use a screw conveyor, and also sometimes people use weight based load cell operation systems, which goes into the blenders. So most of the blender that's used are ribbon blender. Some use paddle blender, uh, uh, and then in case of a large rice mills, they have most of the conveying system is through the bucket elevators. So they have bucket elevators. I'll be showing certain pictures and the videos from the field as well. How it happens is. Even once a paddy has been taken and it's been converted to rice through the milling operations, even before so usually the blender is put in the mill after the sortex, or so, depending upon the market that you're planning to operate with. And there is direct feed of from the sortex through the bucket elevators. It's conveyed to the hopper, and in case of continuous operations, and then to maybe manual feeding or automatic feeding of FRK through a bucket elevating system. And you have a blending unit where based upon the level of automation that you want, you can have load cell based operations, and then you have cycle based operations where you do blending at different cycles. And in case of continuous blending, it is so in these kind of batch system, it is like a particular level amount of FRK, and for white rice goes into the blender, then all the gates get closed, it moves into the blending, then this batch gets into the storage, and once this goes into storage, the other systems open up, and the material get filled in. And once the all the material from the blender dumps into the storage, then the weighed in system comes into the blender again, and then the cycle continues. In case of the continuous operations, it usually they have a cylindrical kind of a blender, and if you have an extra grader at your facility, where you have a rice grader, you can convert that rice grader also into a blender, tilting it into a particular angle, so that the rice can be conveyed, and and also having some grooves with which could be customized. And if you want, I'll be able to share with you the designs of those later, where you can have inside the cylinder, or inside the grader, you can have flights in the inside, so that or the baffles, which also results causes the efficient blending. So in this case, the FRK and the normal rice gets fed into the blender, and it keeps fed at a particular flow rate. It blends and then goes into the storage system. This is just the position of the blending where you usually put in the rice mill. So once the paddies come, the destoning, hulling, and other operations, it is usually kept after the sortex, so that in certain usually the FRK should resemble the normal rice. Most of the cases it resembles the normal rice. In certain cases, the sortex is capable of detecting FRK and may remove the FRK from the rice stream. So that's why we keep it after the sortex. And yeah, I'll just quickly some of the people who are making FRK units. We had the recent interactions with them, and their costs and components. So most of the in cases, the earlier days. In India, particularly when they were initially starting off with the pilots, they were most of the FRK conveying for the blending operations from the and the normal rice. They were using vibratory feeder and conveyor feeder to into the blender. But the problem with the vibratory feeder is over the period of time you need to continuously monitor and calibrate, or else the windings becomes a problem. You need to monitor the frequency, so that as per the set vibration, there is adequate amount of FRK that is getting fed into the blending for blending operations. But nowadays it's been more into a kind of a load cell based operation. So this is one of the blending unit that's been set up in a rice mill in India, where you have the upper separately for the FRK. You have upper separately for the fortified rice, sorry, for the normal rice, and this is the complete setup where you can see the load cell based operations. This is a kind of a batch based kind of a semi. It's completely automatic batch, or you can say semi continuous operation where it goes into cycles, and each cycle is for making. 50 kg batch, and 49.5 kg of the normal rice, and 1%, so 0.5 kg of FRK will be added into it. And you have also, what happens is once you set the operations, uh, the it has a gate. The gate operation closes here, and the FRK and the normal rice, it gets dumped into the there's a collection unit here, and as per the weight it gets dumped into it, and then FRK and the normal rice hopper gate closes, and the storage dump gate opens, and then it gets dumped into the blending unit, and this gate get closed. So once it gets dumped into the blending unit, the blending operation starts, and the cycle starts to continue. And once the blending is done, so probably say for a 15-second operations, or so this needs to be calibrated as per your requirement. And once that cycle is completed, this gate opens, and the dump gate gets closed, and in the meantime, the other batch will get weighed and gets into the storage chamber. So it goes as a sequence, and one after the other. Once all the rice from the blending unit gets dumped into the packaging, then this storage unit, or this gate gets closed, and from the storage, which has been weighed for FRK and normal rice, goes into the blending, and then the operation continues again. Yeah. So this is about the blending unit and the equipment that's been kept for fortified rice. In terms of flour fortification, it's kind of pretty simple. It's not that complex, in as it compared to the blending of for rice with the FRK. There are different methods for flour fortification. Yeah, and this source is from the micronutrient initiative now, which is called Nutrition International. So that all the images and all the flow diagrams has been taken from their the book for flour fortification. Just wanted to quote the source. Yeah. And in terms of gravity feed, it's just based on the weight, where the so in case of rice, the wheat flour fortification, or just the maize flour fortification, it is just simply the addition of premix into the wheat flour once it's been rolled and grinded and set. And usually there are different way. The simple one is the volumetric feeder, but it's also the cheapest one. The mid range is the gravity feeder, which based on the weight, using load cell operations, so it needs to get dumped into the wheat flour or the flour conveying system. And in case of a typical the loss in weight feeder, it's mostly used in continuous systems, where based on load cell operations, and as per the set formulation, the premix and the wheat flour gets weighed and moves into the system continuously. In terms of gravity feeder, the component, so usually it's kept on the top of the floor conveying system. So once it gets added to the floor conveyor from the premix into the floor conveying system, it has sufficient time and and distance, and mostly it's a screw conveying system. And all these compo the premix and the floor gets blended properly. And there is also kind of a very small, probably most of you might have heard of Sanku systems, which is also very good cost-effective dosifiers, which also can be placed directly on the floor conveying system, where the premix can be conveyed based on weight and directly into the floor stream. So this is one example for the volumetric feeder. The only problem with though volumetric feeder is less expensive, efficient. The thing is, if there is a change in the bulk density, because if there is a change in the density, then the weight of premix also changes, and that the dosage also changes. So that needs to be taken care of in case of volumetric feeders. In terms of oil fortification, most of the oil fortification system where they're fortifying with vitamin A and vitamin D, you have a pre-mix blending tank where you initially mix the concentrated premix with a certain amount of oil at a particular dosage that is prescribed, and then it has been pumped to the fortification tank, which has an agitator vessel as well, and is also set up at a particular temperature. Usually it is a jacketed vessels, and blended for a particular period of time and then go for packaging. So even in oil fortification systems, you have batch mixing operations and continuous operations where the stream of the preservatives and the fortificant gets added into the oil directly and goes into the fortification storage tank. In terms of batch mixing operation, the advantage of preparing the pre-blend is that it ensuring that the fortificants are efficiently blended into the oil that it needs to be dispersed with. And the most important component is the agitator system, and it's also a jacketed vessel which enables the temperature maintenance probably around 40-45 degrees Celsius, and also efficiently mixing the fortificants with the oil. Mawuli, as I finish, if you want, you can add more into this oil fortification. The thing with salt fortification is that it is just spray mechanism. It's similar to flow fortification, where we use a screw conveyor through which the salt moves in, and where during the salt is getting conveyed, the solution of potassium iodate, in terms of iodization of the salt, it gets added into the salt through spraying, and then sufficiently conveying through the screw for mixing. Nowadays, there is the other component that has come in for salt along with iodization. It's also double fortified salt, where they add encapsulated ferrous fumarate, where in that case the encapsulated ferrous fumarate formed by different technologies gets blended with the salt using an octagonal blender. Yeah. So I would stop here, and I will open it up for questions and discussions if there are any. Yeah. Mawuli, if you wanted to add further, you can put more into this. Yes.
Thank you very much, Danie. And I think that you've covered all the essential points. I think when it comes to equipment, it's really understanding also the importance of having the standard operating procedures in terms of the maintenance of the equipment, as well as the calibration of the equipment. And then in some industries, you have an alarm system when something goes wrong. For example, like Danie was explaining, if the micronutrient feeder on a flour line gets blocked, there will be an alarm system that would be released to show that there's a problem and it will be corrected. And of course, there are other important areas of where you install, for example, your feeder for flour. It needs to be, for example, a minimum of 3 meters so that the mixing is very homogeneous before it goes out to packaging. And then, like Danie was explaining, you have the continuous system, you have the batch system, and in all those processes, there are mixing systems, there are agitation systems that are installed to make sure that there is homogeneity and the food product is well fortified and before it goes to packaging. So thank you very much, Danie. I don't know if we have some questions in the chat, but maybe I will ask Vitalis if you can play the video from SNC Tech just to show the oil fortification process using this batch system, whilst we also wait to see what questions participants have, because we are not going into breakout rooms for the different equipment. I think participants can just raise their hand, put their questions or put their questions in the chat, and after Danie and myself, we can try to respond to them. So Vitalis, please, can you show your screen and go to, if you can go to the platform, the VFair platform, to the exhibition booth, and then we pull up the video from the SNC Tech.
Dû à la carence en micronutriments est un problème de santé publique au Burkina Faso. Elle touche toutes les couches de la population. Pour remédier au problème, le Burkina Faso, à l'instar d'autres pays de la sous-région ouest africaine, a décidé de faire fortifier certains aliments de grande consommation comme les sels en iode, la farine de blé tendre en fer et en acide folique et les huiles végétales en vitamine A. Pour accompagner le gouvernement, la SNCTEC, leader national de la production d'huile raffinée de coton et de soja, a adhéré au programme de fortification depuis 2007 avec l'accompagnement des partenaires comme Helen Keller International. Elle met chaque année sur le marché national et international des millions de litres d'huile raffinée de coton et de soja enrichie à la vitamine A. Le processus débute par la pesée précise de la vitamine A par le laboratoire. Cette vitamine A est ensuite incorporée dans une cuve prémix pour un premier mélange homogène. Le mélange est transféré dans une cuve principale où un barbotage renforcé par recirculation est réalisé afin d'assurer une homogénéité parfaite. Un échantillon est prélevé pour analyse en laboratoire afin de contrôler la conformité du taux de vitamine A. Après validation, une dernière vérification est effectuée avant l'embouteillage pour garantir la stabilité et la qualité du produit final. Tout au long du processus, des instruments de précision sont utilisés pour assurer un dosage rigoureux répondant aux normes nationales et internationales. Grâce à ce protocole rigoureux, la SNCTEC offre aux consommateurs des huiles enrichies, saines et conformes aux normes nutritionnelles.
Yeah, thank you, Vitalis. Thank you very much for just showing that video on how, in the case of oil batch system, you would have that mixing done with the vitamin A in the batch stainless steel tank, and then it goes and pumped into the storage tanks and homogeneously mixed before they take samples to go and do the analysis in the quality control, and then it goes into packaging and ensure that the vegetable oil complies to the standard before it's packaged for the market. And one of the observations, if you note, the packaging material from SNCTEC is in opaque. It's in opaque colored, yellow colored
packaging containers.
Packaging to protect the vitamin A from direct sunlight, because also vitamin A is sensitive to light, and so it keeps the integrity of the vitamin A in the oil. And also they also do other quality checks like the peroxide value, as well as adding antioxidants like vitamin A and tocopherol to protect the vitamin A so that it gets to the consumer. So we would take questions. I don't know, Vitalis, are there questions in the chat?
There is one question which been mentioned, like what are the key challenges that have been faced in operating the equipment in general within the West Africa context? Yeah, so I'll just give a brief, not particularly to the West Africa context, but in general, what experience that we faced when setting up a production unit or a blending system. So one of the most important component is to building the capacities to operate the equipments, and once the manpower is trained to operate the equipments, the next the one that comes in is the preventive maintenance protocol that needs to be maintained for the equipments. That is in terms of whether the set temperature is what is actually being reflecting into the whether it is for the oil fortification or it is for the rice fortification, is the set temperature. If the temperature in the display is it showing 40, if it is showing 45, is that what is we are getting in the jacketed vessels, or if in the extruder, if the temperature is being set at 65, is that the temperature that's been recorded in the barrel and also in the dryer. So the preventive maintenance is one of the challenge which needs to be addressed too, so that there is no hiccup in when you're running the equipment, or and also you have the another challenge is the documentation of the production that's been made. In terms of so that also comes as a compliance part for a quality assurance component, where you start off from the raw material section till the production, till the dispatch, checking the quality as well. So complete documentation of the process and the procedure, whether if there are any critical control points that needs to be there, that are maintained and monitored, and good manufacturing practices are maintained, and if there are any deviations, you'll have a recall. So this is kind of getting this into practice is what kind of a challenge, and getting to know what needs to operate. So this operational of the equipments, it comes with experience. Though we have a book with the guidance and the manual and everything, there might be minor tweaks and nuances that needs to be done in the field with the operation that is happening, and that comes with the experience as well. Yeah, over from here. The in terms of probably might be in West Africa, what I could assume, what we had the interactions earlier is that one is one good thing will be to have in country capacities developed for local production of the machineries in terms of blending, or the manufacturing, or people trained to repair and install the system. So if case of any breakdown or shutdown or any troubleshooting is required, there will be capacities that will be able to support it.
Yeah, thank you, Danie, and maybe also to complement that, the response in terms of the challenges in the context, for example, of oil, but also in some cases, even for others, cereal flour like maize flour. It's really doing an industry assessment of the industries that are ready to go into fortification. You need to deploy some technical capacity to go and do an industry assessment to understand how they set up, because every industry is set up in a very unique way. And so you need to understand how the industry has been set up, understand the floor plan, and then understand where to install your equipment. And then based on that industry assessment, you need to design the floor plan in such a way that you install the equipment to harmonize with the existing system. And then you also need to develop the standard operating procedures for the installation, the maintenance, the calibration, as well as all the record-keeping system that needs to go with handling the new equipment and the fortification process. And once you do that and you understand what equipment is needed, is now in the case of oil, for example, you need to identify the fabricators of the premix tank, and you need to understand the capacity of the pumps, the capacity of the premix tank, and based on the capacity of the industry to also understand whether it's going to be a continuous system or a batch system, and then work with the fabricator of the equipment to be able to fabricate the equipment based on specifications, including the agitators, the pumping system, the piping system, and even the quality of the material that you are using. The other thing is, for example, for vitamin A fortification in iron tanks, vitamin A is also sensitive to metals. So if an industry, for example, is using iron tanks, you need to put an epoxy in the tank, coating in the tank, so that the oil doesn't come directly in contact with the metallic residues, especially, for example, if the industry is close to a sea, where there's high levels of rusting and there's a lot of iron in the tanks, it can affect the stability of the vitamin A. So you put a coating in the storage tank. And when you're storing the vegetable oil, you also need to have understanding of how long you can store it, and then it goes into packaging. So all of that requires technical support. Sometimes when we also train people and experts, they can be promoted, they can move on. So capacity reinforcement is a continuous thing. And so like Danie is explaining, we need to be able to work with all the different sector of industries, rice, wheat flour, vegetable oil, salt, to really consistently understand the gaps, technical gaps, and support them to address them. Because if we don't support them to address them, they may not be able to comply to the standard that is being required by government when it comes to the level of micronutrients in the fortified food. So it requires consistent technical support for compliance and working both on the internal quality control management systems as well as the external quality management systems to be able to get the result that we need. Danie, are there any additional questions in the chat?
Yeah, there is one question on are there any food safety considerations specific to fortification and also related to individual food vehicles? Yes, absolutely. Food safety is kind of a prime concern, not only for the fortified foods, but also for any food. But I'll just mention certain specific pointers that needs to be addressed when you are fortifying foods. The first and the foremost thing is the water that's been in case of rice. If the water that is used, you need to be sure that the water is of good quality. Usually we prefer to use RO water. It should not be having there are levels of heavy metals, lead, arsenic, cadmium, mercury. These all should be within very limited ppb, or it should be absent in those kind of situations. And so the water quality is to be maintained. And in terms of the flour and the other components that's being used, the other important component that needs to be taken care of is also the microbiological properties of the flour that's been taken in as raw materials, whether there are any mold infestations. So the microbiological parameters. And the another safety features which is kept in flour fortification as well as in rice fortification is that all the blending channels and before it goes into packaging, they are fixed with the metal detectors or magnets, which has been kept so as to prevent any metal particles that might have worn off or come out during the blending operation. So that is also one of the important safety parameters. Apart from that, there are guidelines for critical control points in terms of the temperature maintenance. And if the oil temperature is not maintained properly, then there are a lot of chances for the formation of at high temperatures. Usually that level of high temperature is not used in oil fortification, but in case if the temperature shoots up, it can result in formation of peroxides. And if there are free fatty acids by hydrolytic rancidity or so, then that could also affect the quality of the oil. So these are some. So if the quality assurance component, which includes both the good manufacturing practices in terms of the hygiene of the manpower who is operating the facility, and also the hygiene of the operating units that's been maintained, and also all the construction and the production units are kept in a controlled environment, then we can prevent most of the safety considerations in terms of dust or the breaking of light or any other broken particles coming in contact into food. And apart from that, during operations, you have the critical control points, the temperature maintenance and checking of the raw materials, whether the incoming raw materials are of good quality in terms of mostly the microbiological components, and that also enables to ensure that the food vehicles that's been fortified are safe and good for consumption. Yeah, I'm just mentioning few. Probably, if we can connect, and I can give you a long list of exact parameters that needs to be and the levels that needs to be maintained. Yeah.
Yes. And maybe to complement Danie's point, and Danie has covered all the essential points essentially, but just to complement is that we under normal circumstances for fortification, your food must already be ready for consumption, ready for packaging before you do the fortification. So industries need to put in place the quality management system, the good manufacturing practices, the hazard analysis, critical control points that they need to check for safety and quality before in the production chain, before the food is fully produced and safe, and then they can do the fortification. And so documentation and record keeping systems and putting in place a team that ensures both the quality and safety under the hazard analysis, critical control point management system, good manufacturing practices, and the prerequisite programs that needs to go into all of that needs to be ensured before you actually do the fortification.
I think there is a Dr. Nitika has raised her hand. I think Dr. Nitika, please go ahead.
Yeah, thank you so much, Dr. Danie and Mr. Mawuli, for such an elaborate discussion. And I can actually sense, how much you are involved in the fortification, and the excitement always comes in the way we talk and we express ourselves. And sometimes the time duration that is given to us seems very short, and we really want to convey a lot from our end, from experiences and everything. Well, just to give a brief introduction, I've been working as a business development and partnerships manager with Barnlit, and we already had a session before this session, this one. But just out of curiosity, like the talks that we have been listening from the past 2 days have been very insightful, very engaging, all the speakers, or everything. So first of all, a very big thanks to Mr. Mawuli for conducting such a wonderful event despite being virtual, but it doesn't seem like, because to be very frank, it has been a very learning experience, especially for me, because I've been listening as a learner, not as an expertise, just to learn what exactly is going on in fortification. To add to my question, like I've been a part of RICE breeding program because I did my PhD from IRI Pusa Institute, where at that duration my team was developing golden rice. So I remember how much a big challenge for them to develop at that time, like 10 years back. Now talking about rice fortification is comparatively, I think, less challenging. I won't say the challenge has gone completely, but less challenging in that sense. There are many different approaches. And from the past 2 days, and definitely the projects and the initiatives being taken care by the government, NGO groups all together, is very helpful. We are pushing really hard for fortification, especially in the developing regions. But on the ground level, if we see, like the companies we have, those are actively participating in, let it be the oil fortification, flour fortification, mostly are the big players, right? What about the medium millers? Do they really have the capacity to have this kind of setup when it comes to rice fortification? And especially when I talk about India, right? Because if I talk about India, we have a large number of rice FRK millers, right? but are they really equipped to that level that they can assure the quality of the fortified rice that they bring in the market? First of all, this is my first question. If I talk about oil, definitely in comparison to oil, flour, and rice, oil is at the top. People are really much educated. Capacity building is there. They know the quality checks are there. Then comes the flour. Flour, so we are still pushing for the flour. And third is the rice FRK. So first of all, what about those millers? Uh, I mean, because if we see these machines, they're really big setups. So what about the millers who really want to engage into it, irrespective of whether it is an Asian continent, I mean, India, or in any of the African countries? Because when I talk to millers, they say that they really express their interest, but they can't because they don't get the support, let it be in terms of finance or in terms of education or literacy in terms of fortification. Secondly, you mentioned about Sortex, right? Definitely a Sortex, because it has its own calibration, so it might discard the fortified rice. Okay, we are adding the fortified rice once the sorting is done. But what about the consumer acceptance? I I know a few people, they think that, oh, it's something wrong with the rice, because they really don't know that basically that yellow rice is something which is fortified, and they throw it out. So do we really think that at the consumer level, are they really aware of this kind of product? Because then again, at the end, what all efforts we are doing here is that the end user should benefit from it. Despite all these efforts, I've been into this field of fortification from past maybe 1 year, and there is a lot of money that has been flowing, a lot of efforts has been going on, a lot of projects have been going on. But do we really have any statistics on the data or data on the consumer level that how good they are accepting in? Because whenever there's any color change, any physical change, it's a human nature, we really take it as negative thing. So I mean, I know there are efforts, but still there is a gap, in between those things. Third thing, the last question. We know about rice fortification, RES, it is fortified. But when it comes to quality assurance, quality control, do we really have some robust methods and easy methods, not the big setups, to assure that yes, the quality is still maintained before packaging, right? Other than the certificate of analysis, which is being provided by the premix providers or the fortified rice, like the miller. When it comes to the miller, when it's blending, how do they rely upon and how robustly we are actually monitoring the quality? Because what happens is we all get into processing part, right? But how strictly we are monitoring, sometimes that lacks. I remember when I was in India and I went to this flour mill in Vishakhapatnam. It's a very big flour miller. And I asked them, like, they were fortifying voluntary at that time, like maybe 7 years back. And I asked them, like, don't you have any setup for your internal testing of a sample? Because you are one of the biggest mills in Vishakhapatnam. And they said, see, it's not mandatory inspection by the government yet. So what we do is once in a month or as and when required, we send the samples. But on the packet, it was really printed F+. And when we check these samples, not particularly that sample, but let it be the oil sample or flour sample, it comes out that the sample is not fortified or the values are not coming. But every time you cannot have an HPLC setup with you. So how do we tackle all these kind of challenges so that all the efforts that are being put from money to manpower is actually comes in an efficient way and we really see something really good coming up? That's some, you can say, my thoughts, my feedback, my questions. Whatever
Yeah.
you can talk.
Thanks, Dr. Nitika. So I'll just touch around some of the pointers that you mentioned. Yeah. So the fortified rice for the blending systems that needs to be put, it's not only for the large scale rice miller. So just to put out some stats for the benefit of everyone. So, since we are having people all around the world, so in India, yearly, almost around 40 million metric ton of fortified rice is being currently produced, and to supply this amount of 40 million metric ton in the public distribution system, particularly for the government social safety net program, there are almost around 18,200 plus rice millers who have installed blending units where they blend. They take paddy, they convert paddy to rice, they blend it with the FRK, and they give it to the government system, where the government then distributes it to the public through the public distribution system. So for the blending units, not all these 18,000 rice millers are large scale rice millers. So only around 20 to 25 when we had initial landscaping, almost only 25 to 30% are large scale, and most of them comes into the medium scale. And the medium scale rice millers, the blending unit that can be customized for the large scale, for the medium scale, and even for the small scale. So the range of operation, it can be customized. For the medium scale rice millers, the cost of the blending unit for the complete setup, or it won't come more than 10,000 US dollars. So that is the range that is with the capacities that's been developed. That is the cost that's been put up, and most of the medium scale and the small scale, even the small scale rice millers, because if you see in West Africa and other places where wheat flour fortification is happening, most of the rice, the millers or the wheat flour fortifiers are all medium scale millers, and the dosifiers are designed in such a way that it's easy to use operations for those purposes. So the same has been done for rice fortification as well, considering different drivers, rice millers into place, so that the systems can be put and support them. That is one. And in terms of the awareness, okay, I agree that there needs to be continuous awareness. Government is keenly working on, and I think there have been a lot of misconceptions and myths around the fortified rice, considering it as artificial plastic and floating and getting discarded. The quality needs to be better. So if you look into the fortified rice that's been given now, there's been a huge improvement, and there are a lot of training and capacity building that has gone to address the the floating issues that were there in the rice, which is because of the extrusion operation not been done properly. And now most of the places, the floating issues are almost sorted. And in terms of the awareness, people are also being made aware. The government has put up a lot of collaterals. Now the collaterals are also put up in the fair price shops where the distribution points are, and it's also made sure that they keep informing the beneficiaries as well that the rice they have been provided with, it is fortified with iron, folic acid, and vitamin B12, and it's not to be discarded, it's to be consumed. Though we don't say that it's 100%, but it's work in progress, and I think eventually we'll reach there. And yeah, so that is in terms of awareness. There is continuous awareness that's been generated. There are several government events like Nutrition Day and World Food Day and other events where the Food Corporation of India and other stakeholders, they do the kind of all the awareness activities related to this food, not only with fortified rice but also with the other fortified staples. Yeah, and the coming to the last point in terms of the quality control and the quality assurance, rapid testing particularly, or the quick methods or point of sight testing method, which is very very important apart from the conventional lab methods which are available to test. It always builds the confidence to the rice miller to know whether they have blended it properly, also to the FRK manufacturer to know whether they have actually added the right premix into it. So we also did an intensive exercise of identifying, and there were one, I think probably you, since you're from Bioanalyte, you would know, I check, but we also worked with and found there are other methods as well, kind of quick and rapid reagent methods, which when interacts with iron, it shows the ferric form of iron, and based on this, it's kind of semi-quantitative, and based on that, with the color differentiation scale, the miller or the FRK manufacturer will know how much amount of iron is being added into it. Though there are research happening for the other forms of iron that is being present, whether they are actually adding ferric pyrophosphate or different forms of iron into it, and also for folic acid and vitamin B12, which is work in progress with the institutions like Indian Institute of Technology, Delhi. But there are reagents like the one that I mentioned for ferric and ferrous foam, and we have done this pilot trials in a lot of godowns in the states where we were working for capacitating the technical capacities of the state in terms of the and most importantly improving the quality. And there in the rice mills, also in the blending units, we added this rapid testing kits, and we also checked whether the blending efficiency is proper, and we also capacitated the millers, and most of the millers are also now procuring, and it's very less. It's almost $10 to $15 per bottle, where you can do at least 25 to 30 tests, where you just add it and we get the. It's similar to the iron spot, but it's not that chemical heavy, and it's easy to use and easy to handle, and it has a good stability as well. So there are research that is happening. I just gave you an instance, but I think eventually we'll be there, and the quality is one of the important component, because we need to ensure that the component that or the staples that we are fortifying is adequately fortified, that it enables the end user to reach the benefit that we are intending to provide this fortified staples for. Yeah, so these are some of the initiatives, but there is a huge way to go, and there are people and partners working together on that. Yes, thanks, Dr. Nitika, for that question. I think I would have sufficiently answered to your points. Yeah,
Dr. Danie, it was really wonderful. Yeah, thanks. Thank you so much.
thank you.
Yeah, thank you so much, Danie, for that, and also thank you, Nitika, for those observations. Of course, this is the platform that has been able to bring together the different sectors and components of fortification from the private sector, different private sector components that are involved. Whether it's from the food industries themselves, the equipment producers, but also the micronutrient premix producers and the analytical devices for testing micronutrient in fortified foods, as well as the partners and the stakeholders that are supporting food fortification, including our development partners and donors. And so it's really a platform for exchange. We do hope that with the current situation we'll be able to have more frequent virtual engagement on specific components that also bring on board the food industries and address specific technical gaps, and be able to really ensure that large-scale food fortification is yielding the result we are all looking for, which is contributing meaningfully to reducing micronutrient deficiencies and its public health impact. I don't know if there are additional questions, but please feel free also to reach out to myself or Danie if you have questions. As Danie was responding to Dr. Nitika, I was going through the lobby and also going through the exhibition hall just to showcase, to see some of the virtual booths and stand of the partners and there are a lot of information there, and you can go there and download relevant technical information and connect and chat. And we are drawing to the closing ceremony, but it's been really an exciting two-day virtual exhibition. People have come in, people have gone. We had over 600 registered participants, and we had funding support also from GAIN, from Helen Keller International, from Q Impact, of course, CRS as the leading agency that is, working with all the different partners to put this together, and our private sector institutions and regional institutions. This is really, it's been very, very exciting. And so please, we want to make sure that nobody holds back their technical questions. Please, you can open your microphone, you can share, you can ask questions as we work towards the next 15 minutes to go into the closing session. And once again, we are also grateful to PATH for the South-South collaboration, effective collaboration. And we are looking forward to the possibility of producing fortified rice kernel in West Africa like we are doing in India, leveraging the technical experience on national fortification alliances to improve coordination even in India and among states in India, and really reinforce the whole South-South collaboration, also with Sri Lanka, with Indonesia, with Pakistan, with all the South countries and West Africa and Southern Africa and Eastern Africa. So yeah, we're really looking forward to really leveraging all of this to advance the micronutrient fortification of staple foods across the South-South nations. Please feel free, come off mute and share your ideas. Go ahead, Danie.
Yeah, Mawuli, I think my colleague is here, Saurabh. He has put a message that he wants to give some field experience. Saurabh, you want to go ahead quickly and keep it to a very short one? Saurabh, can you hear me?
Yes, Danie. Am I audible?
Yes.
Yes, you are audible. Very short one, please.
Yes, thank you so much. I mean, just a quick response to what Dr. Nitika has raised, a very pertinent questions. So 2 point is on the ground, what we are ensuring is we are doing the joint monitoring visit with the food safety officers, where we provide the on-site trainings to the rice millers, both of mid-level size, also of large rice mills. Number 2, we are training to the food analyst also. And thirdly, we have done the food of FRK audits in few of the states in India. And just to update you, very recently during the Poshan Pakhwada, I mean, this is a Hindi word, but in English, this is a fortnightly nutrition awareness program where we leverage the existing platform to raise the awareness on the rice fortification programs. And it has been documented that the rice is available everywhere and most of the issues has been resolved. But of course, there is always a scope for improvement. Thank you so much, Dr. Mawuli and Danie, for providing the opportunity.
I would just like to thank Saurabh for pitching in and explaining the things. And I mean, I know, I'm also an Indian, so I do understand what you said. So it's really good. It's what I asked was not about questioning the efforts. It's just that supporting it and to implement it, because people are doing a lot of efforts, pushing in all possible ways. And we mainly need to look about what gaps are being left so that we can focus on them and can fill them up so that we can have a smooth path and then a regular process where everyone could be benefited from all the efforts that have been put in. And I mean, I really appreciate you coming in and explaining the things to us, and especially Dr. Danie as well. And thank you so much.
So once again, we would like to take this opportunity to express our gratitude to PATH and to all the contributors and speakers for this particular session and all the participants. It's been very insightful looking into the various equipment for rice fortification